So, part 11, chapter 9. I hope you guys noticed that I changed my chair. So, I think that is making less noise than it was doing before. Let's hope. So, we talked about service level and how to set the safety stock. Again, if I want to have an 85% service level, I need to add some inventory in the reorder point. So the reorder point will be the demand over lead time, so average demand times the lead time, plus Z times the standard deviation. And Z is the Z score on that Z score table that gives me 85% service level. So I just told you guys about the Z table, right? And I wonder how many of you guys remember what is the Z table. Yes, here it is. I know you guys remember this, at least looking at it for quite a bit of time. Let's go back to that, right? So here on the middle I have the probabilities or the percentage, and here on this first column and this first row you guys can find the Z-score value, right? So let's say I need the Z for 99% service level. So if that is the question, if I'm asking, what is the Z for that percentage, I need to go here and find 99%, so close to that. So have 98, 98, 98, 99.6, 0.4, 0.1. So here I have 99.01. And then this value here is 2.3. So here's 2.3 and 3. So 0.03. So this 2.3 plus 0.03 equals to 2.33. Okay? This is when I have the percentage and I need to find the Z-score. In the other way around, sometimes I can have the Z-score and I want to find the percentage. So in this case, okay, what is the percentage value for a Z-score of 0.85, right? So then I have to go to the 0.85, so 0.8 is here, 5 is here, and I can find that the Z-score for 0.85 is 80%. Okay, so here's my 80%. So hopefully you guys remember. If you don't, please send me an email. I can explain that in more details if you have a problem looking at the service level here. Okay. So why do we want the Z-score? So we want the Z-score to put into the safety stock calculation, and this is the math for calculating safety stock. So safety stock will be the Z value, and the Z value will be depend on the service level. So the problems will give you the service level, for example. The company wants a 95% service level, and then you need to find Z on that table, say, okay, for 95%, this is the Z-score. And then times the standard deviation of the demand over the period of time, times the square root of L, and L is the lead time. Okay? So one thing that's important is to have everything in the same unit. So if it's the standard deviation of the week, it's the lead time have to be in weeks. If it's the standard deviation of the month, the lead time have to be in months. Okay? Because sometimes the lead time is multiple weeks, and the standard deviation is from 1 week, that's why we need the square root there. Okay, and just to understand why we need the square root, this what this slide is talking about. So if I want an average of 1 week is 75. If I want an average of 3 weeks, is just multiplying 75 by 3, and then you have the average of the week will be 225, right? 225. If the standard deviation is not like that, you can't say that the standard deviation of 3 weeks is 3 times the standard deviation of 1 week. Okay, you have to use that square root to actually make it into a normal distribution of 3 times in this case 3 weeks, right? So again, so if the standard deviation is the average 75, standard deviation is 15 for 3-week period, the standard deviation will be 26. Okay, so no, not 45, not 3 times 15, 26, because that's 15 times the square root of 3, what we just saw, the square root of the lead time. Okay, and this is the problem using a queue system. So I have a demand of 10 units per week, assuming 52 weeks per year. Ordering cost is 45. Holding cost is 12. Lead time is 3 weeks. Standard deviation of the weekly demand is 8 units. And we want to have a service cycle service level of 70%. So we calculate the economic order quantity. We know how to do that. And first thing, and very important here, we have to differentiate the weekly demand from the yearly demand. So and that's very important for all the problems, exam, everything that you guys are going to do, assignments and all. So the capital D, it's the weekly demand. Lowercase d is the weekly or daily demand. Okay, so economic order quantity uses yearly demand. You're right, exactly. So square root of 2ds divided by h, 2 times 520, which is the yearly demand. We just took the weekly and multiplied by 52, times 45, which is the ordering cost, divided by 12, which is the holding cost, 62 units. So we know that every time we're going to buy 62 units. So if I want to calculate the reorder point, first we can calculate safety stock here. It's separated, but you can put it all the same formula as well. So it's going to be z-score times standard deviation of the demand over lead time times square root of lead time, right? So the z-score for 70%, if we go back here, 70% here we can find on this table. So we'll be around here. It'll be the 0.52. 525 times the standard deviation, which the problem just gave us was 8 units here, times the square root of lead time, which also the problem gave to us, and that's the safety stock, 8 units. If I want to calculate the reorder point, is going to be the demand 10 times L lead time plus 8 safety stock, 32 units. So basically what we're saying is, okay, every time that you get to 38 units, you need to put an order. Okay, how much you should put an order for? 62 units. Okay, so 62 is the economic order quantity. You're going to go up. You're going to receive after 3 weeks. You're going to go up, and then you consume it again. Okay, and just to add the inventory cost to practice a little bit, here is the total annual inventory cost for this cycle, not considering this part was not considering safety stock, and we added the third part, considering safety stock. So Q times 2 divided by H, that was the average inventory times holding cost, plus demand divided by Q times S, which is the ordering cost, plus safety stock times holding cost. So that's a total inventory cost.